Okay, we are going to graph this function f of x. So as you can see, the big idea is we are going to start with finding our vertical and our horizontal asymptotes. So in order to find the vertical asymptote, you are going to take the denominator and set it equal to 0 and solve. In this case, that solve is pretty easy. So my vertical asymptote is going to be the vertical line, x equals 3. The next thing we're going to do is we're going to find the horizontal asymptote. In order to find the horizontal asymptote, you're going to take the ratio of the leading coefficients. So in other words, I'm just going to kind of bring our function down here real quick. So the leading coefficients are the numbers in front of x. So if you notice, in the numerator, the number in front of x is 2. In the denominator, as we know, if there's no number in front, the number is 1. So our horizontal asymptote is going to be the ratio of those two numbers. So in other words, y equals 2 divided by 1 or 2. So our horizontal asymptote is going to be the line y equals 2. Okay? So like before, the next thing we're going to do is we are going to graph our vertical and our horizontal asymptotes. So let's go and do that. I'm going to bring these down so that I don't lose anything here. So our vertical asymptote is x equals 3. Our horizontal asymptote is y equals 2. And I'm going to grab the function 2. I'm going to bring that on down just for reference. Let me put it, this is fine. So let's graph our stuff here. Vertical asymptote's at 3. Horizontal asymptote is at 2. Looks like I could make this graph a little bit bigger, which is fine. So from here, and this is the big step, this is where things change for us a little bit. I'm going to look at that vertical asymptote. I'm going to look at this vertical asymptote. I'm going to choose 2 numbers to the left of it and 2 numbers to the right of it. The big thing here is when we do those numbers, because we're going to plug them into the original function, so everything is based on the actual points themselves. So this is our origin. We're not doing a translated origin like we've done before. So, for example, my vertical asymptote is at 3. So I'm going to choose 2 numbers to the left of 3. Would you guys agree? 2 is to the left of 3, 1 is to the left of 3. So I'm going to go, I'll do those in order. I'm going to do f of 1, because that was to the left of 3. So I'm going to take my original function, and I'm going to evaluate it at 1. So I get 2 times 1 plus 1 over 1 minus 3. 2 times 1 is 2 plus 1 is 3. So this is 3 over negative 2. So that point that it passes through, our graph is going to pass through the point 1. I'm going to convert that to a decimal, negative 1.5. So let's just go and plot that. We can plot that now. So again, this is 0, 0. I'm going to plot the point 1, negative 1.5. So that looks like it's right there. It's right. Sorry, I missed it. 1, negative 1.5. These are going by 2s. So it's kind of right there. I really want to emphasize, because we are using the original function, we have to use the original origin for our points. Okay? Now let's do the next point. So we said 2 was also to the left of our value of our vertical asymptote. So I'm going to go find f of 2. So that gives me 2 times 2 plus 1 over 2 minus 3. The numerator 4 plus 1 is 5. 2 minus 3 is negative 1. So it is negative 5. So I'm going to be plotting, wow, my graph is just not great, my coordinate grid. I'm going to plot the point 2, negative 5. So if you notice, here's my origin. I go over 2. I'm going to go down 5, so it's kind of right there. I'm a little bit off, but we can still see it, so it's about there. So that left-hand branch hugs the horizontal asymptote, passes through our 2 points, and I'm just going to extend that vertical asymptote a little bit, and it's going to hug that vertical asymptote. I'm then going to repeat the process to the right-hand side. So now, again, that vertical asymptote is at 3. I'm going to choose 2 numbers to the right of 3. So, for example, 4 and 5. So I'm going to go and do 4 and 5. So let's do f of 4. Which becomes 2 times 4 plus 1 over 4 minus 3, which is 9 over 1, which is 9. So we'll plot the point 4, 9. So in this case, 4 up 9. Let's see, 1, 2, 3. Oops, sorry, I'm going by 2s again. 2, 4, 6, 8, 9. So right there. Okay, then I'll choose another point. So I'll choose the point, I'm going to use 5 because 5 is to the left of the vertical asymptote. And we get 2 times 5 plus 1 over 5 minus 3, which is 11 divided by 2, which is 6.5. So again, this point's going to be off my graph a little bit. So 6.5 is, I think it's right about there. So in this case, let's look what that graph looks like. I'm going to erase some of this work here so we can kind of make this graph a little bit better. So this graph is going to hug that vertical asymptote. And then if we extend the horizontal asymptote, it's going to go and hug that horizontal asymptote.